In the name of God, hello everyone. In this session, we introduce the finite volume method for two-dimensional diffusion problem. The methodology used in deriving discretized equation in the one-dimensional case can be easily extended to two-dimensional problem. To illustrate the technical, let us consider the two-dimensional steady-state diffusion equation. The general form of conservation equation in pure diffusion equation be divergence um, divergence gamma gradient plus equal 0. In two-dimensional, this divergence gamma gradient is dphi divided dxi plus divided by j. In two-dimensional term is only covariant equation plus s equal 0. If we use divergence theorem for in two-dimensional, we have grid in two-dimensional. Main grid P, E right hand, left W, south S and N. This is main grid and the surface name is E, small w, N and S. We use integrate all control volume D, integrate control volume dV equals 0. Divergence theorem, this integrate all control volume or volume change to surface. Integrate or control surface gamma dphi divide dx I plus divide by j dot n dA plus s delta v equal 0. Okay. And in the surface is minus j. In the surface is minus I plus j plus I, the n vector. Therefore, integrate w gamma dphi divide dx I plus dphi divide by in wn is dot minus I dA plus integrate on n gamma dphi divide dx I plus d phi divided by j dot n is positive j dA plus integrate in E gamma d phi divide x I plus y j in E n equal positive I dA plus s gamma d phi divide dx I plus d phi divide y j minus j dA plus s delta v equal 0. Okay. I dot I minus I equal I dot I equal 1 I dot j equal 0. Okay. Therefore, is um, is the result to gamma minus d phi divide dx d phi divide dx r w plus gamma n j d phi divide dy a n plus gamma d phi divide dx a on e minus gamma d phi divide dy a s plus s dv equal 0. If we use a central approach to approximate this finite difference, this equation is minus gamma gamma w a w d phi divide dx on w w d phi divide dx equal minus pw. dp minus w divide plus gamma n a n e n minus phi t divide delta y plus gamma e a e phi phi e minus phi p delta x minus gamma s a s phi p minus phi s delta y plus s delta v equal 0. Okay. we will rearrange this equation and generate general form of algebraic equation. What is dimensional grid used integrate mm, uh, divergence theorem and in this step use central approach for approximate this term from phi divide dx or e equal phi e minus phi p delta x d phi divide dy on s equal p s ds is s approximate from p divide dp divide dy on s equal bp minus phi s divide dy bp minus phi s divide delta y and on n is n equal to use forward difference Pn minus phi p divide delta y. By substituting the above expression into equation 53, we obtain when the source term is represented in the linear form S delta dv equal SU plus SP phi p. S S equal S delta V equal SU. SU is SAP is a slope of this line SAP. SAP and if this X and this is excuse me, this is phi and this is S. This point is SAU. Um, this equation can be rearranged as is general form AAP phi P, AW phi W, AE phi E, AS phi S, AN phi N. This is AAP, AW, AS, AN. General Lattice equation form for interior node. AAP phi P equal the general forms AAP. phi P is summation of NB, NB, NBC, NB is neighbor coefficient of major cell AF, NB, CNB, and AAP equal AAP equal A prin P minus SP, and A prin P equal sigma ANB equal AW plus AS plus AN plus AE. Okay. Mm-hmm. AW and AAP is sigma ANB minus SP. The phase area in a two-dimensional case AW equal in two-dimensional mm-hmm. um, AW A E A S A N AW equal AE equal delta Y, delta Y, and this delta X, AS equal AN equal delta X. Okay. Uh, use Gauss-Seidel or inverse matrix solve algebraic equation. This algebraic equation. Finite volume method for three-dimensional diffusion problem. In a steady state dimensional situation governed by in three-dimensional we have gamma divided z direction. It is a three-dimensional grid. Three-dimensional grid in used to drive three-dimensional only add one term to previous two-dimensional term, and this term in z direction. And general form of algebraic equation is AAP, CAP, AW, CW, AAE, CE, AAS, AAN, AAB, FAB, AAT, FAB, and SAU. And this is coefficient of this and AP equal summation of sigma A and B minus SP. Thank you. Goodbye.